All right, so we're not starting really, well, we're starting new material, yes, but we're not going to start the next chapter, chapter 4, until after Thanksgiving. So we're not starting a new chapter until after Thanksgiving, but I did want to go over some of the stuff with matrices in between now and then. Also, chapter 3 tests, I did have the grades in, they are up. If you want to do the makeup points, talk with me, work with me, because I know next week, for the most part, Monday and Tuesday should be fine. I know Wednesday, Thursday are going to be just chaos. Controlled chaos anyways. But if you want to do the makeup points, talk with me. We'll work it out. We'll find a time for you to come in and get those done. And do the makeup points on those, earn half the points back that you lost. Because part 2, pretty much everybody did very well on part 2. Part 1 could have been better. But we do have the makeup points, so you can go back, see what it is. I worked through most of them, not all of them, but most of them. So you can kind of see one of the examples or a few of the examples how to do, and then you'll do the other one. But we'll work that out. Now, matrices. We have done matrices before. We covered matrices at the beginning of the year. And most of what we're doing today is not going to be new. A matrice is a rectangular arrangement of numbers. That's all it is. It has dimensions, rows by columns. So this one here, matrix A, is a 3 by 4 because it has 3 rows and 4 columns. One thing we didn't talk too much about was elements. Each number inside the matrix is an element. And we denote or describe or depict them as a lowercase of whatever the letter we use to describe the matrix itself. So here, matrix A, we use capital letters, so capital A. Each of the elements in the matrix is going to be a lowercase letter followed by 2 numbers. Those 2 numbers tell us the row and column. So A21 would be the number in the second row, first column. So it would be -1. If we said A14, A14 would be the first row, fourth column. So 14 would be 6. So let's look at an example of this here. So we're using matrix A, this one here, to answer the following question. Now the first thing it's asking us to state is the dimension, so our rows by column. So there are 2 rows, 4 columns, or 3 columns, so it's A2 by 3. So those are the dimensions. It's a 2 by 3. Second part of this question is asking us to find element A21. A21. So that's second row, first column. So we're going to go to the second row, move over to the first column, which would be 9. Because the number in the second row, first column. So second row, first column is 9. So A21 is 9.
So 2 means
Row, column. Yes. Welcome. Yep. Questions on finding the dimensions of A or element A21? What would A22 be? -9. Second row, second column. Let's look at this next one here. State the dimensions of B, and then we're going to find B32. Well, the dimensions of B are 3 by 2. Now, element B32, so to find it, we would go to the third row, second column, which would be -1. -1. Because we go down the third row, over to the second column, it tells us it's -1. That's it. What would B1, 2 be? -8, first row, second column. So 1, 2, -8. First row, second column, -8. Because the first number tells us how far to go down, second number tells us how far to the right we're going. Always start in the top left. Questions on these here? So naming elements is new. We hadn't done that before. Now this is new because we haven't really talked about specific types of matrices. There's a few that have special names. The first one, if the matrix consists of exactly one row, we call it a row matrix. If it exists and only has one column, it's a column matrix. Doesn't matter how many elements are in the column, as long as it's one column, it's a column matrix. If the number of rows and the number of columns are the exact same, it's a square matrix. So 2 by 2, 3 by 3, 1,000 by 1,000 is a square because the number of rows and the number of columns are the same. And the last one's a zero matrix. Doesn't matter the dimensions, but every element is zero. Then it's a zero matrix. They're just special names for these matrices here. Next thing we're going to do is nothing really new. It's our matrices when we add or subtract two matrices together. When we talked about this previously, we said we can add and subtract two matrices as long as their dimensions are the same. They have to be the exact same. So if we look at A here, because A is our 16, 2, -9, 8, and it's wanting us to add B to it. As we see here, A is a 2 by 2. B is a 2 by 2. Since the matrices dimensions are the exact same, we can add the corresponding elements together. So 16's corresponding element is -4. Then we'd have 2 plus -1. Then we'd have -9 plus -3. And lastly, 8 plus -7. So we're adding the corresponding elements together. 16 and -4, 2 and -1, -9 and -3, and 8 and -7. Well, 16 plus -4 is 12. 2 plus -1 is 1. -9 plus -3, -12, and 8 plus -7 is, and that's it. Now we also did these in the graphing calculator. Because we saw with the graphing calculator, really, we can solve or do any kind of matrix operation we want. We did addition and subtraction in the graphing calculator and pretty much came to the conclusion, for the most part, that adding or subtracting two matrices, I can do it pretty much as fast by hand as I can in the calculator. Because if we wanted to do this in the calculator, first thing we have to do is second matrix. Go over to edit. And we're going to say the dimensions are 2 by 2. And I'm going to plug matrix A in. So 16, 2, -9, 8. Once we get it typed in, we go second quit. Then we're going to go second matrix over to edit. But this time we're going to go down to matrix B, which is also a 2 by 2. -4, -1, -3, and -7. Second quit. So once we get them typed in, we want to recall them. And that first list where it just says names, let's just recall it. So we have matrix A plus second matrix B, and it tells us that it's 12, 1, -12, 1, which is what we got by hand, yes? And again, typing these in, just simple addition, subtraction by hand, in the calculator doesn't make a huge difference, especially time-wise. Questions on this here? Find the following. So B minus C. Well, B is -4, -1, -3, -7. And we want to subtract from it matrix C, which is 8, 6. Yes? So C is a 2 by 1. B is a 2 by 2. Yes? Are the dimensions the exact same? No, so this here is not possible. We cannot add or subtract the matrices that do not have the exact same dimensions. So let's go and type it in, matrix C, 2 by 1, 8, 6. Second matrix B minus second matrix C, dim mismatch, dimension mismatch. Because again, it's saying the dimensions are not the same. Check dimension, so check size dimensions of list or matrices. So they're not the same dimension, so it does not work. We can't subtract. That's all there is to it. How do we feel about addition and subtraction? Do we remember doing this? Do we feel good with it? Do we need to see another example of adding or subtracting two matrices? Do you feel good with this here? Okay. Because we've done add addition and subtraction. We talked about that in chapter 1. It's been a bit, but we've talked about it before, yes? Yeah, okay. The next thing we're going to talk about, multiplying by a scalar. When we multiply by a scalar, we take whatever that number is. In this case, we're saying 5r. We're taking the number 5 and multiplying it by our matrix R. Which all this is telling us to do is take every number inside this matrix, every element, and multiply it by 5. And again, just doing a matrix scalar, this scalar multiplication on matrices, it's almost just as fast as do it by hand, type each one into, yes. Because we could type the whole matrix R into the graphing calculator. We can set A as a 2 by 3 and do -12, 8, 6, -16, 4, 19. Second quit, 5, second matrix A, enter, and it would give it to us. But it'd almost just be as fast to just write it out and say 5 times -12 is -60. 5 times 8 is 40. 5 times 6 is 30. 5 times -16 is -80. 5 times 4 is 20. And 5 times 19 is 95. Now, I'm not saying just doing it all in your head is faster, but we can still use the calculator and just type in 5 times -12. Enter. 5 times 8, 5 times 6, 5 times -16, 5 times 4, 5 times 19. Because we can just type each one of those in and it'll give it to us faster than we can type it into the calculator. Do 5 times the matrix. Yes. I know we're going at a little bit of a pace, but we good with this here? It's starting to come back to us. Yes, we remember doing this. It's been at least 2 months, but we're just multiplying each of those numbers by 5. Here it's asking us to multiply each of these numbers by -4, yes? So we could start off saying -4, 0, 3, But really our first step is what? Is there anything saying that I just can't jump to that second step and write that -4 multiplied through that matrix first? No, we can jump straight through it. We don't normally because we want to try to keep our numbers straight. Especially since this is the only thing we're doing. There's nothing wrong jumping straight here. There's -32, 0, -12, 8, 4, 16, 8. Now, if you want to, we could set matrix A as this matrix T here. It's starting matrix, type the whole thing in. And then say -4, second matrix A, enter, it'll give us the answer. But again, I think if you want to do that, that is perfectly fine. There's nothing against it. But I think for most of us, if you find it faster to just do -4 times each element, do that. If you find it easier to plug it into the graphing calculator and do it that way, do it that way. One is not necessarily better than the other. It's what's going to be easier or helps you do it. That's more important. Questions on this here? So for the most part, have we covered anything really new today? No. Elements is kind of new a little bit. We ready for something new? Because what have we, operations-wise, we've done addition, subtraction, and a scalar multiplication, yes? The only thing we really haven't done yet is actually multiplying two matrices. But I'm getting ahead of myself because this is first. Multi-step operations, -4b minus 3a. I think we remember doing some of these here. Keep going. There we go. Other side. There we go. -4b minus 3a. This is where we started to see that doing it in the calculator and doing it by hand starts becoming a little bit quicker. Because when we started combining these scalar multiplications with addition, subtraction, the calculator started to be able to do it a little bit quicker than we could. Because first thing we need to do is rewrite this. Now with these here, I would definitely write the scalar out front. And the reason I say that is because we're not just multiplying by a scalar, we have to do the scalar and then we have to follow it up with the addition or subtraction. We have two different things we're going to have to end up doing. So it helps us kind of keep it straight. Now the first one, we're going to multiply through by that -4. Now in the second matrix, we have a choice. We can multiply it through by 3, positive 3. And if we do, the negative is going to stay put. Because if we multiply through by just positive 3, we're still going to subtract the 2. Okay? The other option is we could multiply, just take the whole -3, multiply it through B, or A in this case, that second matrix, yes? But since I took the negative out, I took the negative from with the 3, that sign in the middle is going to become plus, because I took that negative away, it has to switch to plus. Does that make sense? Now at this point here, we can start multiplying. -4 times -4 is positive 16. -4 times 8 is 32. Negative 4 times positive 2 is negative 8. And negative 4 times negative 3 is 12. Our second matrix, negative 3 times negative 9 is positive 27. Negative 3 times 12 is negative 36. Negative 3 times 2 is negative 6. And negative 3 times negative 6 is positive 18.
So if there was a negative 27, positive 36, positive 6, and negative 8.
Right. If we left the negative in the middle, yes. So essentially, it would just switch all the signs of it. But it will end up giving us the same result. Because when we go to combine it, because if I think you left the negative there. So here, if we didn't take the negative out, we get 16 plus 27. I think you got 16 minus negative 27, which gives us the same thing. Instead of having 32 plus negative 36, you have 32 minus 36. So what we end up getting, 16 plus 27 is 43. 32 plus negative 36, 32 minus 36 is negative 4. Negative 8 plus negative 6, set it backwards, is negative 14. And 12 plus 18 is 30. As long as I didn't mess the numbers up. Yep. Yep. 6, 18, negative 36, 27, 16, 32. Yeah. Mm-hmm.
So there should be it should be what?
Let's see here. Yeah, so then we would subtract 16 minus negative 27, negative 8 minus negative 6, 21 minus negative 18, 32 minus 36. So it will give you the same values. Yeah. Now we can also type these in. Now to type these in, we're going to have to type A in as a 2 by 2. Negative 9, 12, 2, negative 6. Second quit, second matrix. Over to B, which is also a 2 by 2. Negative 4, negative 8, 2, negative 3. Now we said negative 4 times matrix B minus 3 times matrix A. 43, negative 4, negative 14, 30. So it gives us the exact same answer. So especially once we start getting more than one of them, it starts making it easier just type it in. But if you feel comfortable doing it by hand or feel more comfortable doing it by hand, might as well just do it by hand. Questions on this here? Questions on either so far? Because even if we wanted to do this here, we could do it in the calculator pretty easily. We go second matrix, 3 by 2, negative 5, 3, 6, negative 8, 2, 9. Second quit, second matrix. Over to edit, we type in B, 12, 5, 5, negative 4, 4, negative 7. Yes.
It would be 16 minus 27.
16 minus negative 27.
Would that be a plus?
Yep. Yeah, because 16 minus negative 27 is the same as 16 plus 27. Yes. And then you'd have 32 minus 36, which is negative 4, negative 8, minus 6, negative 12, and then 12 minus 8, or 12 minus negative 18 gives us plus. So it'd still get us to the same answers. Does that make sense? And for the next one, negative 6b plus 7a would give us this here. So especially for this one here, where we're getting such big numbers, the calculator is going to do it way faster than we ever could trying to type it in. Questions on this here with the scalar multiplication, addition, subtraction. Now here's the actual new part. We're multiplying by matrices. We're multiplying two matrices together. Now for us to be able to multiply two matrices, one thing has to hold true. And that's that the column of the first matrix has to match the rows of the second. If the columns of the first match the rows of the second, it says we can multiply them together. And interestingly enough, the new dimensions is going to be the rows of the first by columns of the second. So if the columns of the first match the rows of the second, it says, yes, we can multiply them together. And if the rows, and it tells us then that the rows of the first by columns of the second are the new dimensions. So let's see how this works. So if we look at this here, a times b. For us to be able to multiply, since a is first, its columns has to match the rows of the second, which is the rows of b. So the columns of a is 4, the rows of b is 4. Since they are the same, it says yes, we can multiply matrix A by matrix B. We can multiply those two together. And our new dimensions is we're going to take the rows of A by the columns of B. So it's now going to be A3 by 2. So this here just tells us, yes, we can multiply them, and yes, these are the new dimensions. Question on how we just check to see what, if we can multiply, and what our new dimensions are, because that's all we're doing so far. So let's look at B. A's columns is 3, B's row is 5, so we're doing A times B. Number of columns for A is 3, the number of rows for B is 5, so we can say here, no, because they are not the exact same, this is not possible, because the rows of the first, or sorry, the columns of the first has to match the rows of the second. Since the columns of the first thing we're multiplying is 3, rows of what's second is 5, 3 and 5 are not the same, so it says we cannot multiply those together. Questions on this here? Let's look at 1A. Columns of the first is 6, rows of the second is 6, so it says what? Yes, we can multiply these together. We can do A times B. And the new dimensions would be 4 by 2. 4 rows, because we take the rows from the first one, 2 columns from the second. Questions on that before we look at 1B? Columns of the first is 2, rows of the second is 3, so that tells us what? No, not. possible. You don't have to write this down. I'm just looking at 1a, but I'm going to flip it. Because we know multiplication works in any order, yes? 2 times 4 is the same as 4 times 2. So if, for 1a, I flipped it, we said b times a. Columns of the first has to match the rows of the second, yes? Columns of the first is 2, rows of the second is, do those match? No, so this here is not possible. So the interesting thing with matrix multiplication is that order matters. It's one of the few places where multiplication does not work in either order. Order matters with multiplication. Questions on these here? Now, when we multiply two matrices together, the way I think of it is over, down. So I'm going to get a highlighter out. Because when we multiply, we're going to go across the row and multiply it down the column. A is going to multiply with E, B is going to multiply with G, and we're going to add those two products together to give us our first element of the product. Then we're going to do a similar thing. We're going to go over and down, then do A times F plus B times H, and that gives us the second element here. Now, if B had a third column, we would go over and down again. If we had a fourth, we would just keep going for each column that the matrix has. And once we run out of columns, we go to the second row, first column, and do it again. So the whole thing with multiplication is over and down. Then we're going to do it one more time because there is two sets, and it gives us this here. I would definitely say with multiplication, we are definitely pushing the line of doing it by hand being faster than just doing it in the calculator. So that's not negative. So we're going to work through this here. I'm going to show you how to do this by hand. We're going to do one by hand, but really, I think after this, we're going to do everything in the calculator. We're going to let it do it for us. So the first one we're going to go is over and down. So what we'll have is 6 times negative 5 plus negative 3 times 3. If there was a number after our negative 3 in that first row and a number below 3 in that first column, we would add their product too. We would just keep adding the products of the next two elements until we run out. Questions on this so far? We kind of see what we're doing over and down. First and first, second and second, then third and third. It would just keep going over and down. Now that we're finished, we're going to do it again. We're going to go over and down. So we'll have 6 times negative 4 plus negative 3 times 3. So as we go over one element in the row, we're going down one element in the column, multiplying those, and then we add all of those products together. Questions on this here? So we kind of see how this is working. We see how this works, yes? Is there another column in matrix, in the second matrix? We did it once, we did it twice. Is there a third column? No. So what that says is we're done with that first row. We've done every multiplication of over and down with the first row. So now we move to the second row, first column. which would be negative 10 times negative 5. Then we're going to add to it negative 2 times 3. And that's as far as it goes because we have 2 and 2. Then we're going to do it one more time. Now at this point here, I would just take each of those lines, 6 times negative 5 plus negative 3 times 3, just type the whole thing in, let it do it for us. But 6 times negative 5 would be negative 30. Negative 3 times 3 is negative 9. 6 times negative 4 is negative 24. Negative 3 times 3 is still negative 9. Negative 10 times negative 5 is positive 50. Negative 2 times 3 is negative 6. Negative 10 times negative 4 is 40. And negative 2 times 3 is negative 6. And lastly, we would just simplify those terms together. We would add and subtract where needed. Questions on how we did that? Because really we can take graphing calculator, say second matrix A is a 2 by 2, 6, negative 3, negative 10, negative 2. Same quit, second matrix B is also a 2 by 2, negative 5, negative 4, 3, 3. Okay. And we can put them right next to each other, and it's understood, all right guys, focus in still, that it is multiplication and we do get the exact same thing. But also if we wanted to, we could say second matrix B times A. We can flip the two matrices, and as we kind of already stated, these are completely different products. But we're going to finish this